For this example, we are given two functions. We have function f and function g here, and we are supposed to show algebraically that they are inverses. So in the directions, it implies that f and g are inverses of each other. It's telling us we have to show that they are. So we know that they are, we just have to show it. And how do you show algebraically that two functions are inverses? Well, there are two calculations that we need to make. We need to do the composition function in each direction. So we need to do f of g of x, and we also need to do g of f of x. We need to do those two calculations. And if you have functions that are inverses, both of those calculations are going to give you the same answer, and what you are going to get is just x for the answer on both of those. So we already know what the answer is going to be. In the directions, they told us they're inverses. If two functions are inverses of each other, when you do the composition function, you get x for an answer. So we have to do two calculations. We're going to get x for an answer each time because we already know that they are inverses. So first, let's do f of g of x. To do the calculation f of g of x, we're going to be taking function g, and we're going to be putting that in place of function f. So we need to take this entire function right here, and we need to put it in place of the variable in function f. One of the ways that you can do that is to do it the way I just described it, or your first letter that's here, copy down exactly what that is, except in place of the x, just put parentheses there. So f is the first letter, so I'm going to copy this down, and I'm going to put parentheses where the x is. So that would give me 2/3 parentheses plus 2. And then in place of the parentheses, you put in the second letter, which is g of x. So I'm going to copy that down here. 3/2 times the quantity x minus 2. So this is what f of g of x looks like. Right now I need to simplify that down. That usually takes 2 or 3 steps. But I know that we're going to get an answer of x because we already know that these are inverses. You can do this simplification a few different ways. One of the things you could do is work on these innermost set of parentheses, because we do have nested parentheses. We have one set of parentheses inside of another set. So one of the things I can do is get rid of this innermost set. We would do that by taking the 3/2 that's in front and using the distributive property, multiply that into both of those terms. That would still leave me with this 2/3 in front, still leave me with the plus 2 in the end, but simplifying what's inside of here, 3/2 times x is 3/2 x. And 3/2 times a negative 2 is a minus 3. The innermost set of parentheses are gone. We can now work on this last remaining set. Again, we have a value in front of here, so using the distributive property one more time, I can get rid of that last set of parentheses. Here we have 2/3 times 3/2. If you multiply across the top and across the bottom, you would get 6/6. And 6/6 is equal to 1, so we would get a 1x. The other thing you might recognize is that 2/3 and 3/2, those are reciprocals, and anytime you multiply reciprocals together, you do get an answer of 1. So 2/3 times 3/2 x gives us 1x, or just x. 2/3 times a minus 3 gives me a minus 2. And then we would have the plus 2 on the end still. And now those 2's cancel out, and we just get an answer of x. To show algebraically their inverses, we need to calculate the composition function, f of g of x, and the answer should be x. We also need to calculate g of f of x and do the same thing. So g of f of x, that means we need to take function f and put that into function g. So I'm going to take this function up here, I'm going to put that in place of the x's here. Again, a good way to go through and create this is to copy down your first letter, but in place of the variables, put parentheses. So I'm going to copy down function g, which is 3/2, and then we have parentheses, and then I have an x, so I'm going to replace that with some parentheses, and then a -2, and then we close our parentheses. So that is what function g looks like if we replace the x with some parentheses, and now in place of that x, I'm going to put the second letter, our second function name, which is a 2/3 x plus 2. So now it's set up. Now we just need to simplify, and again, we know f and g are inverses, so I already know the answer is going to give me x. We have nested parentheses again. Let me get rid of this innermost set. If there was something in front here, I would distribute it in to get rid of those parentheses, but there's nothing here in front of this innermost set of parentheses, so I can just drop those off. And now inside the remaining set of parentheses, those 2's are going to cancel. And 3/2 times 2/3 is 1. So we end up with 1x or just x. If you are given two functions and you need to algebraically show that they are inverses, you need to do these two calculations. That's how you do that algebraically. And you should get x for an answer each time if they are inverses of each other.